Next topic is lines of curvature as parametric curves. So the necessary and sufficient condition for line of curvature to be along the parametric curves or the parametric curves on the surface to be the line of curvature is that f is equal to 0 and m is equal to 0. For the necessary part, let us consider that the line of curvature are along the parametric curves, or our parametric curves are the lines of curvature. The equation of the parametric curves is given by du dv is equal to 0, and the equation of the lines of curvature is dv square minus of du dv du square efg lmn is equal to 0, or du square into em minus fl plus du dv into en minus gl plus dv square into fn minus gm is equal to 0. So, by comparing these two, as the lines of curvature are along the parametric curves and lines of curvature are always orthogonal. So, the necessary and sufficient condition for parametric curves to be orthogonal is that f is equal to 0. Using these conditions, we have em du square minus gm dv square. Since du dv is equal to 0 and f is also 0, so this can be written as e du square minus z dv square into m is equal to 0. Since du and dv are arbitrary changes that depends upon our choice, so this is not necessarily 0 for all the points or for all the changes du dv. That means m must be 0. Since parametric curves are along the lines of curvature and lines of curvature are always orthogonal, and the necessary and sufficient condition for parametric curves on a surface to be orthogonal is that f is equal to 0. So, f necessarily be 0, and from this derivation we also have m is equal to 0. For the parametric curves to be along the line of curvature is that f is equal to 0 and m is equal to 0. Now, the sufficient part. As we know, the equation of lines of curvature is em minus fl du square plus en minus gl du dv plus fn minus gm dv square is equal to 0. This is our lines of curvature on the surface, and we are given that f is equal to 0 and m is equal to 0. F is equal to 0 and m is equal to 0 reduces this equation to en minus gl du dv is equal to 0. As first and second order fundamental magnitudes are point specific on a surface, so this difference is not identically 0. That means du dv must be 0, and which is the equation of the parametric curves. So, our line of curvature with f is equal to 0 and m is equal to 0 will be along the parametric curves.